Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today, we're going to be doing Unit 4, Lesson number 9, Graphs of Logarithms. So we introduced the concept of a logarithm yesterday, and today what we're going to be doing is examining the logarithm function a little bit more closely. And we'll start off by looking at how we can graph logarithms by hand. All right. Now, the most fundamental thing about logarithms in general is understanding that they're inverses of exponentials with the same base. So when we look at something like y equals the log base 3 of x, we should automatically know that it is the inverse of y equals 3 to the x. And again, remember, all inverses do are sort of reverse the action of a function. So watch how we're going to graph log base 3 of x. What I'm first going to do is generate a table of values for y equals 3 to the x. All right, so in letter A, it says construct a table of values for y equals 3 to the x, and then use this to construct a table of values for y equals log base 3 of x. So obviously here we'll have 3 to the negative 2, but remember that's 1 over 3 squared, so that's 1/9. Here we'll have 3 to the negative 1, which is 1 divided by 3 to the first, so 1/3. Here we'll have 3 to the 0. Remember, that's 1. Any number to the 0 is 1, except for 0. 3 to first is 3, and 3 to the second is 9. Now remember, whenever we have an inverse, all that happens is we take the xy pair, and we switch it, so the y becomes the x, and the x becomes the y. So now what's going to happen is that the x is going to become 1/9, and the y is going to become negative 2. And then the x is going to become 1/3, and the y is going to become negative 1. The x is 1, the y is 0. The x is 3, the y is 1. The x is 9, the y is 2. All right, let's graph the two. Let me graph y equals 3 to the x in red, and then I'll graph log base 3 of x in blue. All right, so what do we have? We have negative 2 and 1/9. Hard to kind of graph 1/9. Negative 1 and 1/3. Still pretty hard. 0, 1, 1, 3, and 2, 9. 9's right at the top of my grid on this paper. And so we get that classic increasing exponential graph. Let me label that y equals 3 to the x. Okay, I'm going to switch over to blue and do the logarithm graph, so we're going to do this one in blue. So now I have 1/9 negative 2, right? That's the equivalent of this point, right? That one went here. Then I'm going to have 1/3 negative 1. Then I'm going to have 1, 0, 3, 1, and 9, 2. And I'll get the classic increasing logarithm graph. There we go. Look at that. All right. Now, we've got the two graphs. So letter C, where it says to state the natural domain and range of y equals 3 to the x and y equals log base 3 of x, well, that should be relatively easy. Pause the video now and see if you can figure out the domain and the range of those two functions. All right, well, let's first start. I'm going to go back into red. Let's start with y equals 3 to the x. The domain is all real numbers, okay? You can state that either with that funny r, you could do negative infinity is less than x is less than infinity. You could use interval notation, negative infinity to infinity. But I can literally put any value in for x and get a value of y out. On the other hand, notice that all the y values for that exponential function are greater than 0. So y is greater than 0 is a great way to put it, or, if you like interval notation, 0 to infinity. Now, as we switch over to the logarithm, you should notice something pretty clear. In the logarithm graph, although the graph approaches x equals 0, it never hits it. In fact, x always has to stay greater than 0. That makes sense, because it is the same as y greater than 0 for the original function. Likewise, and this is a little bit trickier to see, stay in blue, but the y is actually going to hit absolutely every single number. So the range of the logarithm function is all real numbers, or negative infinity to infinity. Now I can't tell you how important this little piece of info is. okay, it gets to a very fundamental fact about logs. Whenever we take the log of something, I don't care what the base is, whatever is in here must be greater than 0. It's got to be positive, okay? We can't take the logarithm of a negative number, and we can't take the log of 0. All right. There's a lot of important stuff on this first problem, so pause the video now and take as much time as you need. All right, I'm going to clear it out. Then we'll move on to the next exercise. All right, exercise 2 says, using your calculator, we'll bring it out in a second, sketch the graph of y equals log base 10 of x on the axes below. Label the x-intercept. State the domain and range of log base 10 of x. All right, let's bring out the TI-84 Plus. Okay, there's our calculator. Now we want to put this function in. We want to use the window that's on the screen. So let's do it. Let's hit y equals. Now we have to put in log base 10 of x. But remember, right, log base 10 of x is what's known as the common log. So whenever we have the common log, we don't really write a base there. So in y1, let's type in that log button. All right, let's put in log of x. That's it, pretty simple. If you have any other equations in there, obviously you want to get them all cleared out. Now we want to set our window. So let's go into the window. It looks like on this axis, my smallest x value is 0, which makes sense. Remember from that last exercise, I cannot have negative x's or even a 0x, but I'll still set x min to be 0. I'll make x max 10. And then it looks like y min should be negative 2, and y max should be positive 2. All right, everything looks good. Let's hit the graph button. All right, let's sketch a graph. Now, I'm going to sketch actually the graph that I see on the screen. Okay, it kind of looks like this. Now, this is a very deceptive graph because it appears that it intersects the y-axis, that it has a y-intercept, but it doesn't. If it had a y-intercept, we would be able to come up with a y value when we put x equals 0 in. But that would then mean that we could actually raise 10 to some power and get 0, right? Because that's what a logarithm is. But what power would that be? It wouldn't be 0. 10 to the 0 is 1. It wouldn't be negative numbers. 10 to the negative 2 would be like 1/100th. 10 to the third would be 1,000, right? So it never actually hits here. In fact, if we blew this graph up, what we would see is we would see the thing getting closer and closer to the y-axis, but never actually hitting it. And that's really tough for students because they want to believe what they see on the calculator, but the calculator has its limitations. In fact, the domain of this function continues to be the domain we saw last time, x is greater than 0, and the range happens to be all real numbers. All right. I'm going to put away the TI-84 right now. Okay. Pause the video now and draw or write down anything you need to. All right, I'm clearing out the text and then we're going to move on. Okay, let's see how much we understand this. Exercise 3. Which of the following equations describes the graph shown below? Show or explain how you made your choice. All right, what I'd like you to do is pause the video right now and use this question to test how much you know. Now, it doesn't mean you have to get the final right answer, but if you can at least eliminate some answers and get them down to only a couple choices, that would be great. So think about it for a bit. All right, let's talk about it. Pretty much any logarithm graph that you need to be worried about, log base b of x, is going to look like this. All right, where it goes vertical right here at x equals 0, right at the y-axis. All right, but this one on the other hand, well, this one goes, let me go in blue. This one goes vertical a little bit different, right? It goes vertical at x equal, whoops, oh, I don't know what happened there. Sorry about that. It goes vertical at x equals -3, which means this graph must have been shifted 3 units left. That means this one is out. That's been shifted 2 units left. This one's out. That's 3 right. So we're down to here, to these two. So if you got it down to those two, then you understood the shifting nature of this. So how do we now decide which one of those it is, whether it's log base 2 of x plus 3 or log base 3 of x plus 3? Well, here's what I would do. I'd pick a point. Let's take this point. What is that? That's the point -2, -1. All right, let's take this one. Let's see if that's the case. Let's put in -2 for x. Ooh, that's not going to work out well. Let's choose another one. Well, no, let's go with this one. Let's keep going. I realize that there's going to be a little bit of an issue. What is the log base 2 of 1? What do I have to raise 2 to get 1? 2 to the 0 equals 1. So the log base 2 of 1 is 0. And that gives me -1. But maybe I just got lucky. Let's try it actually in log base 3. Let's try this one. -2 plus 3 minus 1. Well, again, that's going to be the log base 3 of 1 minus 1. And that's also going to be 0 minus 1, -1. So that actually also checks. That point is on both of them. Let's try another point. That was annoying. Why don't we try this one? What is this? I can't tell that one. That's somewhere in between. How about this one? What is that? That's -1, 0. Let's try that one. Because that first point didn't help me very much, and that's okay. So now I'm going to have log base 2 of 2 minus 1. Well, what's the log base 2 of 2? Oh, that's going to be 1. 1 minus 1 is 0. Okay, well that's good. But, I'm a little bit nervous. Maybe I should try it in log base 3. Again, it's exactly the same substitution. Well, this is confusing me. Log base 3 of 2 minus 1. Now, the problem with that, right, is that I can't actually evaluate it. I don't know what 3 should be raised to get the number 2. But I know it's not 1, right? So this is not going to be equal to 0. And therefore, after a lot of work, I can say it's choice 3. All right. So this is a log base 2 graph that's been shifted to the left. Now you might say, why didn't I just choose that point at first? Well, quite frankly, that's not the spirit of the Common Core. The spirit of the Common Core is that you should really be testing points. If they don't work, great. Test other points, right? You should try until you find the solution. And the first set I tried didn't work, but the second set did. Told me which answer I needed. All right, so pause the video now, write down anything you have to, and then we'll move on and do some more graphing work with logarithms. All right, I'm going to clear this out. Okay, exercise 4. Determine the domain of the function y equals log base 2 of 3x minus 4. State your answer in set builder notation. Well, the domain, remember, those are the x values that we can substitute into a function. All right, let's try some x values. Let's try x equals, I don't know, let's try x equals 3. All right, would 3 be in there? Y equals the log base 2 of 3 times 3 minus 4. That would be the log base 2 of 9 minus 4, which would be the log base 2 of 5. Now, I may not know what that is, but it's somewhere between 2 and 3, right? Because 2 to the third, or 2 to the second is fourth, 2 to the third is 8. So, they're definitely like, there's some output to that. But why don't we try x equals 0? What would happen? Well, y would be equal to the log base 2 of 3 times 0 minus 4, which would be the log base 2 of negative 4. But the problem is there's absolutely nothing we can raise 2 to get negative 4, so there's no output. No output. So 0 is not in the domain, but 3 is. So how can we find the domain without doing endless guess and check? Well, what we know for certain is that when we have log base b of something, the thing that's in there must be greater than 0. So if the thing in there is 3x minus 4, which it is, that's got to be greater than 0, right? But that means 3x must be greater than 4, and x must be greater than 4/3. If we really have to put it in set builder notation, we'd say all the values of x such that x is greater than 4/3. Note, not greater than or equal to. This isn't a square root problem. Just greater than 4/3. Okay? You can only take the logarithm of positive numbers. Pause the video now and write down anything you need to. All right, I'm going to clear this out. Let's take a look at exercise 5. All right, in the final exercise, I just want to examine a little bit more the behavior of log graphs, and we're going to take a look at log base 10 again. Letter A, it says set up and evaluate an expression for the average rate of change. It's been a little while since we've seen our friend average rate of change of f of x over the interval 1 to 10. All right, so a little reminder, right? If I want the average rate of change, so how fast the y is changing compared to the x, I use this comparison, right? It's really just the change in y divided by the change in x. It's like a slope calculation, right? And I just use this and it tells me how fast y is changing compared to how fast x is changing. So in this case, what I'm going to have is I'm going to have f of 10 minus f of 1 all divided by 10 minus 1, which is going to be the log of 10 minus the log of 1, all divided by, well, I guess 9. That looks like a Q. Let's get rid of that little tail. Okay, log of 10, think about that as 1, right? The log of 1 is 0. You could do that on your calculator, but I encourage you to do it in your head. So we have 1/9. Pretty small average rate of change, right? It really means that for every 9 units that x increases, y increases by 1 unit. But look at what happens if we do the average rate of change from 1 to 100, right? F of 100 minus f of 1 all divided by 100 minus 1. Well, that's going to be log of 100 minus log of 1 divided by 99. Log of 100 is 2. Log of 1 continues to be 0. 99. 2/99, much smaller. I mean, 1/9 is not a particularly large average rate of change, but 2/99 is very small. For every 99 units that x goes up, y goes up by only 2. All right? And that really gives us the interpretation in the last part of this problem. It says, what do these two answers tell you about the changing slope of this function? And it really tells us that the slope is getting much smaller as x gets larger. And again, you can definitely see that from the graph, right? If this was a hill and you were walking up it, right? As you walked up it, it would be getting easier, and it's getting easier because that slope is getting smaller, right? That slope is getting smaller. And that's a classic characteristic of almost all logarithm graphs. Okay. Well, pause the video now write down what you need to, and then we'll finish up the lesson. All right, let's clear it out and wrap it up. All right. It takes students a long time to really become comfortable with the logarithm function, right? It is a strange function. You just were introduced to it in the last lesson, all right? But the sooner you become comfortable with its characteristics, the fact that you can only take logarithms of positive numbers, what the general graph looks like, kind of like an exponential, right? But in sort of a different way, right? It's been flipped over y equals x. The sooner you become comfortable with those, the easier then it will be to do higher order work with logarithm functions. But don't worry if you're still a little bit uncomfortable with it right now. All right, I'd like to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.